All right, this is the last section that you'll be responsible for exam number one, section 3.3. It's no doubt the most challenging. Your calculator is going to bail you out, but not completely. There are going to be two easy formulas that you're going to to have written down in your notes and obviously refer to, and there'll be plenty of practice questions with answers. My suggestion is that you try these. And then, of course, on Tuesday, you'll have your homework will be to do sections 3.2 and 3.3. And then Thursday, I'll have a voiceover explain how the solutions were derived. In either case, averages and variations, percentiles, and what's known as a box and whisker plot. Section 3.3. There's a video. I suggest that you watch this if you haven't watched it already. Focus points interpret the meaning of percentile scores, compute the mean, the median, quartiles using a what's called a 5-number summary, make a box and whisker plot. I'll talk about you don't really have to make it. All you need to know is the 5 values that comprise that box and whisker, which is the smallest value, quartile 1, the median, which is known as quartile 2, quartile 3, and obviously the largest number in the data set. We've seen measures of central tendency and the spread of a set of data when we talked about variance and standard deviation. The arithmetic mean X bar and the standard deviation will be very useful in ladder work. However, because they utilize every data value, they can be heavily influenced by one or two extreme values. In cases where our data distributions are heavily skewed or even bimodal, we often get a better summary of what's going on by using the relative position of the data rather than exact values. We know that the median is an average computed by using relative position. Median is the middle number. If we're told that 81 is the median score of all biology tests, we know that after the data has been sorted, 50% of the data fall at or below the median, obviously 50% lie above 81. The median is an example of a percentile. In fact, it's the 50th percentile. Percentiles range from 1 to 99. We see that the 60th percentile that's marked in this histogram, we see that 60% of the scores on a biology test, if you receive, let's say you got a 79.5 and you were told that that score was in the 60th percentile, what that implies is that you did better than 60% of anybody else who took the test. Unfortunately, 40% of the class did better than you. All right, relative position. All right, if your score is in the 60th percentile, 60% of the scores were at or lower than yours, and 40% were at or above your score. If you arrange people in a class according to height and you're told that your height is in the 80th percentile, simply means that you're taller than 80% of everybody else in that class. And there you are right here. All right, you're taller than 80%, and 20% of the people in the class are taller than you. All right, 16 people here are shorter than you. 16 over 20.80, 0.80 times 100th, 80th percentile. Gives you a little clue of how we're going to figure out percentile. Right here. You're actually looking at the number of people that are shorter than you, these 16 people, dividing it by how many total people they have, and then change that decimal by multiplying by 100, change that decimal to a percentage or a percentile. If your score is at 89, is in the at the 89th percentile, what percentage of scores are at or below yours? Well, 89%. If the scores range from 100, from 1 to 100, and your raw score is 95, does that necessarily mean that you're in the 95th percentile? No. You could be in the second percentile. Everybody in the class could have got a 96 or higher. So percentile and raw score doesn't necessarily equate. Percentile gives you an indication of relative position. There are several widely used conventions for finding percentile. They lead to slightly different values. For all conventions, however, the data are first ranked in order from smallest to largest. You got to do that. You got to put the numbers in order. If you're doing it pencil and, well, I take that back. You will be doing this pencil and paper, so you've got to order these numbers from smallest to largest. For example, the 50 percentile denoted by P50 here has about 50% of the data values below it and 50% of the data values above it. So the 50th percentile is the same as the median. All right, this is not a universal agreement on a single procedure for calculating, but this is how we'll do it in for the exam purposes. Here's the formula that you got to either commit to memory or not even commit to memory, just have it written down somewhere when you see these problems on the exam. To find the percentile that corresponds to a particular data value that should be given, first order the numbers from smallest to largest. You find the total number of values less than your target value, the value that we're given X. You divide that number by the total number of values you have, and you multiply by 100. Going back to the previous example, there were 16 people in that class shorter than you. There's a total of 620 people. 16 is the numerator, and 20 would be the denominator, which came out to be 0.80 times 100, the 80th percentile. 80th percentile. Notice when you're doing your calculations, you're rounding off. Rounding off simply means if you have a decimal, and that decimal is in the tens places of 5 or more, you're going to round it up to the next larger number. You're rounding off. All right, and the rules are if the decimal in the tens place is a 5 or more, round up. If it's a 4 or less, you just drop it. All right, rounding off. All right, so here's some examples here. He gives us another way of looking at this formula. He has this b over n times 100. Well, b represents the number of values less than your target value. So in this case here, 47 is your target value. So notice the numbers here are ranked from smallest to largest. There's my first time I see 47. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 values less than my target value of 47. So my numerator would be 9. I've got a total of 24 numbers, 9 over 24 times 100. And I would round my answer to the nearest whole number. And that would be my percentile. 65, you're way up here. And let's see, if there's 24 numbers, there's 20 numbers less than 65. 20 over 24, reduce the lowest terms, times 100, change to a percentile. Now we'll do these a little bit later on, these bottom ones. As is the case in mathematics, usually go one way, then we flip the script. Here, I'm giving you a data value. You tell me what percentile it is, falls in, and I give you the number, you give me the percentile. Here, I give you the percentile, and then you're eventually going to give me the number. Now, what's important here is I've done all of these examples in the previous slide, 15 through, well, actually 15 to 26, but initially 15 to 18. You want to change those values to percentiles, and there they are, done out, right? This B over N. B stands for the number of values less than your target value. So for the number 54, there were 12 numbers less than 54 divided by the total N, 24 numbers. Multiply that by 100. 54 is in the 50th percentile. Make sure you try these out because the answers are right here. Quartiles are simply special percentiles. Quartile, see quartile, think of quarters. The first quartile is the same as the 25th percentile. The second quartile, 2/4, is in the 50th percentile. The third quartile, 3 times 25, is in the 75th, equal to the 75th percentile. Quartiles are just special percentiles. And there it is, first quartile, 25, P25. Quartile 2 is the same as P50. Quartile 3 is the same as P75. There is no quartile 4. Quartile 1, 25th percentile. Quartile 2 is the median 50th percentile. Quartile 3 is equivalent to the 75th. 3/4, 75%. 75th percentile. Now, here's the deal. This is the formula where now I give you, before I gave you a value, you told me what percentile it fell into. Now I give you the percentile. You tell me what number fits fits that qualification. But notice the formula here. It starts out with the letter L. L stands for location. So when I do this little calculation over here, it's not going to give me the answer right away. It's going to give me the location of the answer. In other words, it's going to be, when I do my calculations, it's going to be 7 or 8. That's the location. So if I do my calculation, I get 7. I'm looking for the number in the 7th position. This does not give you your answer right away. It gives you the location where to find your answer. It's either in the 8th position or the 15th position. All right, so be aware of that. L stands for location, so there's a little bit more to do here. Now, what makes it even more complicated is when you use this little formula, one or two things can happen. You could get a whole number or not get a whole number. If you don't get a whole number, in the prior exercise, we rounded off. Here, you're always going to round up no matter what the decimal is. Let's say I get 3.2. 3.2 rounding up, not rounding off, is going to be 4. So I'm looking for the number in the 4th position, starting from the smallest, fourth largest number. Now, that's if when you do your calculation here, you don't get a whole number. You are to round up to the next highest one. No matter what the decimal is, you kick it up to the next bigger whole number. What if you do, when you do your calculation, do get a whole number? Well, it's very similar to when you're finding the median, when you have an even amount of numbers. You take the number in that location. Let's say the whole number is 6. I need to take the number in the 6th position, add to it the number in the 7th position, and find the average. All right, so two things going on here. First of all, if we get a decimal when we do this calculation, we round up always. No matter what the decimal in the tens place is, we kick it up higher. If we get a whole number, we take the number in that position, and then we add the next one to it, and we just average those two numbers out. It's a little more complicated than what we've seen. So in this case here, find a number it's located in the 20th percentile, number 19. So I would put K stands for the percentile. So I would put 20 over 100, and I would multiply by the number of numbers I have. Q3, well, Q3 is the same as P75, so it'd be 75 over 100 times 24. P95, in place of K, I would put 95 over 100 multiplied by 24. Of course, I'm using my calculator, but I'm being careful because when I do this calculation, if I get a decimal, I've got to round it up. No matter what the decimal is in that tens place, I'm kicking it up to the next highest number. If it were exactly a whole number, I take the number in that position and I would average it out with the number in the next highest position. So here we have starting with number 19, 20, 21. They've done it all out for you. Notice in number 20, you're looking for the number in quartile 1 position. Well, quartile 1 is the same as P25. 25 divided by 100 is 1/4 times 24 is 6. Oh, wait a minute, I got the whole number. So I have to take the average of the number in the 6th position and the 7th position. All right, so be aware of that. If you get a whole number, you got to take that one in the next one. If it's a decimal, make sure you round it off and um, find that number that's located in that position. L stands for location. It's not giving me the answer straight out. It's giving me the location of the answer. These are all done out. So I would say is go back to, number 19. Try these 8 problems because the answers are all here. It starts off with number 19. So 19, 20, 21, 22, all the way to 26. They're all done out for you. All right. So please try those. The last part is what's known as a box and whisker. There's a way our calculator can actually produce this 5-number summary. It makes it real easy. I don't have to draw the box plot. All I need is to know the numbers that represent the 5-number summary. Those 5 numbers are the low value, which is obvious. The high value will be obvious. What you're doing is calculating Q1, the median, which is Q2, and quartile 3. 5-number summary, better known as a box and whisker plot. And that's what it looks like. There's the tiny number, smallest number. There's the biggest number, the number in the first quartile, the median quartile 2, and quartile 3. This will be obvious. This will be obvious. These are the ones you have to be concerned about. Now, multiple ways of doing this. I could find on my own, well, the lowest number is 34, obviously, and the highest number is 79. That's no big deal. I could calculate the median and the quartile 1, which is P25. Please, here's my suggestion. Rather than putting yourself all through that, you've only got here, what, 2, 4, 6, 8, 10 numbers. Put those in your calculator. That's what I've done here. I put the 10 numbers in. All right, instead of playing around with this, let the calculator do all of the work. I mean, I could explain. If we were in class, I would go through, how you create a box and Worcester and all that. But let me just simplify it. Put the 10 numbers in your calculator. All right, and then go over to a stat, calculate one variable stat. I put mine in L1, and then it gives me everything I need. It tells me the small number, 34, but duh, I kind of knew that. It tells me the biggest number, 79. Well, I knew that. Here's what I'm looking for. Quartile 1, it gives me that answer. It tells me what quartile 2, the median is, and it tells me what quartile 3 is. And all I had to do is put the 10 numbers in my calc, which would take you literally 20 seconds. Input 10 numbers in. Now make sure when you're putting these numbers in, you're either hitting the down arrow or hitting the enter key. All right, so double check that you actually have the numbers. If you get answers that don't agree with one of the four answers given, then obviously you put the numbers in correctly with your calculator. What people have a tendency to do sometimes, they'll put a number in, not hit the enter key, and they left two numbers on the same line. Here again, I got two decimal places, no big deal. For the next set, numbers are large, but gee, there's only what, 2, 4, 6, 8, 10. There's only 12 numbers. It takes about 30 seconds. All on list one. I went to stat, calculate one variable stat. L1 is where my list is at. My values are at. And here's my calculator telling me everything I want. Now, did I need to have it tell me that 664 was the smallest? No, I could figure that out. And I knew what the highest number was, 836. This is what I want the calculator to do. Find quartile 1, the median. Could I find this on my own? Yes, but why put yourself through it? Put the numbers in the calculator. It takes seconds, literally. There's a box plot of what I just did. You can see 39, 52, and 63. 39, 52, and 63. This is the second set of numbers, 706, 766, and 810. And there you see it, 706, 766, and 810. Quartile 1, quartile 2, and quartile 3. The small number and the large number, that's obvious. It's these three that you want to calculate to do the work. All right, so you get something here. Once again, I've got what here? 32 numbers. So I know my low is 100, my high is 134. They all have 100 and 134, all four answers. I could find a median on my own. 32, let's see, that's an even amount. So my median is halfway between the 16th and 17th number. So halfway between 114 and 114, guess what is 114? So already I know it can't be letter C or D. It's going to be one of these two. But why put yourself through that? I mean, granted, it's 32 numbers. It may take you a minute and a half, if that. I've seen some of you folks text. It's like texting. But and something else too. If you're not using your calculator, if you haven't been getting really accustomed to it, you haven't been playing with it and getting adept at it, I don't know what you're going to do on the exam because you've got 2 hours, but you can't be fuddling around. You've got to have all this time been working with your TI. It's not like just pick it up and try to figure it out during the test. I put my 32 numbers in. I went to I went to stat, calculate one variable stat. My values are in L1. There you see it. I went to calculate, and here it is. Here's my minimum, which I knew was 100. My max was 134. That was obvious, but these are the three numbers that I was looking for. Obvious. It's letter A, 108, median 114, and quartile 318. I did the exact same thing with the next one. There were 24 numbers. I put them into my list. L1 I prefer. All right, went to calculate. Went to stat, calculate one variable stat. My numbers were in L1. I press calculate and it gives me everything I need. I knew this already. I knew the max. What I didn't know was 510, 705, 705 for the median, and 1225 for quartile 3. Obviously, where it's right. There's a way of actually having the calculator produce this box plot, but it's meaningless. What you need to know are the 5 numbers: the small number, quartile 1, median, quartile 2, quartile 3, and the larger number. There's no need of having a calculator draw this for you. All you need to know is the 5 numbers represented here. And calculator very nicely gives you those 5 numbers if you enter these numbers in a list correctly. And that is that. All right, hope that helped.